We're going to take a quick look at how you utilize the solubility rules to determine if something is soluble or insoluble in water. Generally, you're going to utilize these rules after performing a chemical reaction or in preparation for performing a chemical reaction to identify if any of the products are going to be soluble or insoluble. If they're insoluble, it's because they precipitated out, forming a solid. If they are soluble, that means they stayed in solution and continue to be aqueous. What you would do is take one species in question, like sodium chloride, and identify if either the sodium or the chlorine is found in the soluble or insoluble sections of your chart. All substances right here are soluble, unless there are exceptions. Halides, such as chlorine, bromine, iodine, with either silver, mercury, or lead, are considered an exception to the rule. So silver chloride would be insoluble, whereas anything else with chloride, such as magnesium, would be soluble. In this case, sodium is up here in the alkali metal ions, so it is soluble. There are no exceptions. So anytime sodium or any other alkali metal is found, it's going to be a soluble salt. The next one would be magnesium carbonate. So either we're looking for magnesium or carbonate. Scan through the top list and we don't find any magnesium, don't find any carbonate. Scan to the bottom list and we say, all right, these are all insoluble. Carbonates are insoluble, except when they're compounds containing an alkali metal. Magnesium is not an alkali metal, so in this case, the carbonate, magnesium carbonate, would be insoluble. And the last one, silver sulfate. Again, we're looking for silver. We see silver over here, but that's when it's with a halide. In this case, it's not with a halide, it's with a sulfate. We see silver down here, it is with a sulfate. So sulfates are soluble unless it's with silver, which it is. So in this case, it's going to be an exception to the soluble rule, and it will be insoluble. So to summarize, you're just identifying whether the positive or negative half is found on the solubility chart, and then identifying if it's either soluble or an exception to the solubility rule, or if it's insoluble or an exception to the insolubility rule.